Okay, hi again. I'm still Roman Ivantsov, but now I'm with Tyler Technologies, a developer for Microsoft, joint project with Microsoft on Microsoft Dynamics using IronPython. So we'll go through this very, very quickly. It's a really short presentation. So Dynamics AX, ERP system. ERP means Enterprise Resource Planning. It means that something really, really huge that covers almost everything in a big company, like let's say Microsoft. And it's huge. It's more than 2,000 tables, 3,000 forms. It has all the troubles of the big system. What we are doing with and it's owned by Microsoft, it's shipped by Microsoft. What we're doing, we're helping, we have expertise in public sector enterprises. We have our own systems for public sector, like municipalities, cities, counties, states, and we are helping to modify Dynamics for public sector. And the challenge we have, as usual, is extreme variability of business processes that change from site to site. For example, one of these things is different fees that these guys in City Hall can charge you or charge business. They come up with all kinds of fees. One of them, false alarm fee. If you come work on Saturday and don't disarm the alarm, suddenly a bunch of police cars show up. Somebody has to pay for this. And how the fee is calculated, the city bills the company or the individual for this, and the amount they charge will depend on lots of things like this. And what is necessary is that the system supports things like this. The person who is actually creating the invoice doesn't need to know all this. It must be somehow encoded into the system. So how we here, when we ship the system, how we provide for these things. So one way is, first of all, hire 1,000 business analysts, send them for a year to the field, collect all these descriptions of all kinds of fees, then 1,000 programmers will code this for years and come up with 1,000 fee types and so on. And of course, this doesn't work because the first customer you hit says, "Oh, do you have this kind of fee?" No. The process starts again. You cannot pre-code all these things. So the second solution we decided to go with is to embed scripting language and let customers write themselves some small scripts implementing these fee types. So we made a choice on IronPython because it's .NET based. It means that interoperability is there. It's Microsoft. It's supported. And Python is a nice language in general. I will explain later why. So what we created is such entity as billing code. It's essentially fee type. It's something that is saved in database, has a whole bunch of information like accounting stuff, taxes, miscellaneous charges, and so on. And also it has extra data values. You can encode like name value, that must be collected at the moment, like the time of false alarm call, how many police cars respond, and so on. They are all custom for this, so users can specify this. And there is a Python script to execute after we collected the data. And Python script has access to all surrounding data, to collect the data and to the invoice itself, to the customer, and to everything in the system. So, but the problem now is what is important in applications like this. You may have very smart formula, very complicated formula. You calculate it perfectly. Yes, exact amount. You saved it, we bill the customer, and suddenly a month later he calls and says, "Why the hell are you charging me $200? My buddy paid $100 for the same." And you have to leave the trace and explanation how the system arrived. As you calculate how, you have to leave the textual explanation of every component of calculation of the fee. So what we did, we provide two helper functions using which you can accomplish this very easily. And actually the result of the calculation is two things, is the amount and the textual details. So here's the example. For example, what could be the code for our false alarm fee, and that's the output, the textual output. So what I would say is that Python as a language is a good choice. It's not scary for the people who looked at it. Although the people who writes this would be a probably kind of professional programmer who knows what he's doing. But in many cases, the people who look at this, they are not very savvy programmers. And all this syntactic sugar of other languages like curly braces and all other stuff, keywords, that can really scare them. So Python has minimum syntactic garbage. It looks like exactly like English. And people can understand what's going on there, even if they don't know Python. That's actually very important. So before conclusions, I want to show you how it actually works, what it looks like. So what you see is the main window of Dynamics IX. I won't show you some of the things like with this false alarm fee. The data collection, custom data collection, is not there yet. It's not implemented. It will be in the next milestone they're planning. But the Python scripting already works. So I'm going to accounts receivable. So what you see here is a lot of items. They all pop up different kind of forms. I'm opening free text invoice. It's called so for whatever reason. So I have a couple of invoices created. This is the header. And for example, if we go into this invoice lines, it's actually in this invoice document. We might charge a customer or business for several things. Each line represents the fee. And so the first column is a billing code. It's actually the fee type. It can be empty, or we can choose some of the predefined fees that we created. And if we go to the definition of this fee, a nice form opens, which has actually the definition of this fee. And on the rate tab at the bottom, you see the fee. What it actually implements, this script, it says base fee $100, then postage, and then I know that customer number 4000 is my good friend, so I give him a discount, 10%, $10. And then I say add total line. So let's just try to execute this. Okay, so all you need to do is just to select billing code from drop-down list, and boom, you see the amount appears there, $92, and here is the amount details, how it was calculated. So if I go and change on the invoice, if I change, it was customer number 4000, if I change the customer to be 4001, and then ask the system to recalculate it, I actually need to clear it before recalculate it because it caches. Now you see they pay the full price.
I missed the data for, how did the user get the data in for when the call was and whether they're ready?
It will be extra. So if the billing code defines this data, so you actually define that these are the values, name, value, name and type, name and type, name and type. So when they select this billing code, the window will pop up.
But you get a form.
A form, yeah, and asking. So fill it, please. They fill it, they click OK, and then we'll calculate this. And this data is not only for calculation, it's for historical records. They must be saved with the invoice.
Is that a static form or is it dynamic?
It will be built dynamically because the...
To say that if you put one value in, you get another set of things enabled?
No, I don't think we would go to this extent. It's just name values, but the list of names and values, it depends on, it's defined in the system. So this way we can actually kind of satisfy all our customers, which whatever outrageous fees that they can come up with. Yeah.
Okay. So do you sandbox any of this IronPython code? If I go import CLR, can I just go to town and call?
This is a good question. It was a big concern, actually, the security, and we went round and round. We don't sandbox it because we consider this it's the code itself, the ability to write the script is restricted ability, and it's administrators, at least administrators in this system who would write this code. So it's not raw code coming from internet, nothing like this, like that. Another thing, we actually stripped it. We explicitly denied permission to access the file system, so on the thread. We decided not to sandbox in the separate domain, which I think it would be overkill and extra complexity and extra risk. So we just deny it, just to make it safe for the user. Although some users will be actually a bit unhappy because they'll say, okay, I have fit table on my disk. Why don't you allow me? It's my disk, my system, I'm administrator. And suddenly the system tells them no access to system API or file system. Boom, that's it. But we will see how it plays in the future. Yep.
Is it possible that you could have somebody using this system logged in as an administrator who opens a web page that has some JavaScript in it that then goes?
If somebody can log in as an administrator, then believe me, he would, if he is a really bad guy, he would much better things to do than follow this script. The whole system, it has huge architecture of security, roles, tasks and so on, access, allowing permissions, access and so on. So we kind of rely on this system. So the access to the form is actually restricted by the system itself. So to see the script or to edit it is you have to have quite high permissions. And nice thing about Python is that it's security transparent. So it means that it's impossible to, from inside Python, to elevate permissions if you don't have any system level permissions, I mean. Okay, so to finish my talk, F5. So it works, Python user-friendly, IronPython easy to embed, some concerns, startup time quite long. IronPython 1.5, I remember, was just half a second. Here it's 5 seconds, and I wish for more out of the box thing for scenarios like ours, so that, for example, for error location, how we get the line number when invalid script. It took us several communications with DLR team to find out the exact procedure. As usual, you go to the script engine, how you investigate this. So there is no help file, so you go to the Python's to script engine object, you start inspect its properties, nothing like this. Python object, nothing like this. Scope object, nothing like this. Then you email DLR guys. Oh, you have to get the stack list, you have to find the final stack frame, and then there, blah, blah. So I wish everything would be just out of the box. Something on the property, boom, here is the line number, here's column number, here's the error message. That's it. Attribute injector, very important. We actually first try to use the Python internal in Python language when the attribute not found. Special method, but then it turns out there is at .NET level there is attribute injector interface. So because actually we cannot predict the object that is used inside the script. It's like invoice dot and then some field name, and it's not a real property on the object. It's a field name in database. So we have to catch this call and go to database and retrieve the actual value to the script. So and it works just great, very easy to use. And again, advice, always leave the trace of what you do, or your head will be at stake when they hunt you. And for example, how you got this number, I have no idea. That's bad. Any more questions? Thank you. Up.
Yeah, I'm just curious. Is this an add-on to Sulfur Dynamics, or is this part of Dynamics?
It's part of Dynamics, but special build for public sector. So for private sector, because some of the things that we are about to release, it's kind of complicated system. We check into the main branch, into our special branch, and so there would be actually two builds, one for commercial enterprises as usual, and one for public sector enterprises. And suddenly in this build, you will see different forms, different columns, different things pop up, which is these kind of things, extra. Nice thing, Dynamics architecture allows these kind of things. Thank you.